Check out these bad boys. Wrong. Anyone that knows how to sex a transformer will tell you these aren't boys, they're big, beautiful girls. Now, I've featured the girls in a couple of videos in the past, most recently where I had two of them wired back to back as an isolation transformer, and then quite some time ago I had the three of them cascaded in series to reduce 240 volts down to about 40 to run an induction heater. As an isolation transformer they performed admirably. Even with a 1300 watt load, the sag from input to output was only about 8 volts. So yeah, that's pretty damn good, I think, for a load like that. And in that video I also incorrectly stated that these are from an IBM 4341 mainframe computer. In fact, from about 1979. In fact, they're from a IBM 4381 computer, about 6 or 7 years more recently, in about 86. Although the 4341 did have 3 big transformers in it, they were of the ferroresonant type, and I've done a video on those as well, but they were integral to the power supplies of the computer, whereas these guys, gals, were optional. They were only fitted when the computer was required to run from 230 volts. That's 415 volts phase to phase, but 230 volts phase to neutral. And there was one of them per phase, and that's why I've got 3 of them. I also mentioned in that video that I tried to see what they were worth. You know, if you wanted to buy a new one, like you won't find these sort of things on eBay very often. If you really needed something like this, you'd have to go and buy a new one, and the lowest price I could find, and some of them were considerably higher, was $750 Australian for something specs similar to this. Well, from what I can gather, the specs of these are. Now they weigh 22 kilograms, so they're not easy to move about. And because you can wire them in multiple ways, like that isolation transformer arrangement, or cascaded to get a different voltage, and I've identified a couple of other ways of doing that, so that there's multiple ways you might want to interconnect these, and for a variety of purposes. So for the variety of purposes, I want to be able to easily interconnect them. Because of their cost, I don't want to dedicate them to any one particular project, and because of their weight, you also don't want to put more than one of them in any particular project, because it would weigh too much to move. So what I've decided to do is make a frame for each of them so that they can be transported more easily, and just to make them a little bit more useful. So I'll show you what I've come up with. And here's what I did. So you can see I've put them in frames made out of heavy duty ply, which is some concrete formwork that I rescued from a dumpster, and with chest handles to make them slightly easy to carry. They're still 22 kilograms, a bit more of all this stuff, so they're not easy to move around. And on the bottom, some rubber, foam rubber stuff, which is hopefully, should I drop it on my foot, will cause a little bit less damage than the frame by itself. And on all of them I tend to put, like this one here, I've already done it, spade terminals, so that it's easy to mix and match, connect things together in various configurations. And the wiring, which I'll tuck most of it down there, but I'll have it coming up there. I don't want to cut off these existing ring terminals, because I could just take those spades off and join them onto there if I needed to. So I'll do something like this, where I can just screw on a spade connector for quick interconnections. And not ideal, a bit sloppy, but I'll come up with something. Maybe some heat shrink over there, But yeah, the idea is that they're separate so that they can be transported relatively easily. They're not dedicated to any particular project, and they can be easily reconfigured as required. That's the plan. Now they have these tappings. There's an earth terminal there which just goes to the frame and into, I believe, an electrostatic shield inside, and a neutral connection, active and then 3 neutrals, or vice versa, but for 200, 220 and 240 volt tappings. But even at 240 volts, the output is not half, it's not 120, it's 130. Then, but maybe at full load of something like a couple of kilowatts, that might sag down to 120. So yeah, there's still, I had these 2 chest handles kicking around. I'd have to buy an extra one for here. But yeah, there's still a bit of work to move, but easier than the bare transformers. So I'll do a few examples of how these things can be wired in various configurations, and why I want to make it easy to do that by those spade connectors. Now, this is what I did in the recent video of an isolation transformer. 2 of them wired back to back, the 2 secondaries connected together, input on one primary, output on the other. And there's a better way of doing that, which is this. Put the 2 primaries in parallel and the 2 secondaries in series. That way you've only got half the current going from 4 amps to 8 amps, going from 8 amps to 4 amps, so half the primary current, and only 1 level of magnetic coupling instead of 1, 2. So you'd expect less voltage sag. Now, with these transformers, the problem is that they don't reduce by 50%. 240 comes out as 130, although under heavy load maybe that would come down to 120, but for lighter loads not so much. And it's especially a problem around here because I'm only about less than 100 metres from the main distribution transformer, so the voltages here are consistently around 250 volts rather than 240, or the nominal 230 that it's supposed to be. So I'd actually be getting 270 out here from, if I put in 250, there'd be 270 volts coming out, which is probably a bit high for a lot of appliances. But it would be easier on the transformers and be less sagging. That'll be the way to go for heavy loads. In the other example, where I put 3 of them in series, cascaded to get 40 odd volts, it was like this. So we had 240 down to 130, down to 70, down to about 38. And again, there's a better way of doing that, because the final primary, the secondary, given 2 kilowatts, it should be about 15 amps rating. So 20 amps or even 30 is way above. And in fact, this final transformer was getting very warm, bordering on hot. So the way to handle that would be to do this instead. Still the same up front, but put the primaries of these 2 transformers in series and the secondaries in parallel. Again, instead of 3 levels of coupling, you've only got 2, and the outputs transformers have only got 6 amps in their primaries, whereas here they had 11, and only 10 amps in the secondaries instead of 20, so it's sharing the load across the transformers a lot more. It's pretty much the same over here, so that's a better way of doing it. And next time I fire up that induction heater, I'll use this method. So you can see that there's all sorts of ways to connect them, and probably quite a few others that I haven't foreseen. So that's why I want to be able to easily connect these in various configurations. So there it is, my big IBM 4381 transformers made a little bit more manageable. So yeah, I'll probably be doing more of these big girls in the future. I might try the induction heater thing using this arrangement, see how it goes. And yeah, so if you want to see that, please give it a like, maybe subscribe, and catch you later.